How do you trace Python exceptions in complex call stacks? Imagine trying to find a tiny needle in a huge haystack. That's what debugging a Python program with many function calls can feel like. When an error happens deep inside a chain of functions, it can be tricky to see exactly where it originated. But don't worry. Today, we're going to learn how to follow the trail of an exception through a complex call stack using Python's built-in tools. When Python encounters an error, it automatically creates a traceback. This traceback is like a map showing all the steps your program took before crashing. It lists the files, line numbers, and function names involved. This is your first clue to understanding what went wrong. The key is to capture and analyze this traceback effectively. Python provides a module called Traceback that makes this easy. The simplest way to see the full call stack at the moment an exception occurs is to use the function traceback, printexc. Just put it inside an except block, and it will print the entire traceback to the console. For example, if you have a division by zero error, calling traceback, printexc, will show you the exact line and function where it happened. If you want to save the traceback for later, you can use traceback format hexc. This function returns the traceback as a string, which you can then log or display however you like. It's especially useful in production environments where you want to keep a record of errors. For more detailed control, you can use traceback extract tb. This function gives you a list of all the frames in the call stack. Each frame contains details like the file name, line number, and function name. You can loop through this list and analyze the call sequence step by step. This is helpful when you need to understand how your program reached the point of failure. Another handy function is sysexcinfo. It returns a tuple with 3 parts: the exception type, the exception value, and the traceback object. Using this, you can access the traceback directly and even re-raise exceptions after processing. When dealing with complex call stacks, it's best to read the traceback from the bottom up. The last entry shows where the exception actually occurred, and the entries above show the chain of calls that led there. Each step provides clues about how your program arrived at the error. A good practice is to always wrap risky code in try-except blocks. Inside the except block, use traceback functions to print or log the traceback. During development, traceback, printexc, is quick and easy. In production, save the traceback string with traceback, formatexc, and log it for later review. If your application has many layers, the full traceback helps you see the entire story. It shows the sequence of function calls, making it easier to identify the root cause. For very large or complex systems, consider integrating error monitoring tools that automatically collect and analyze stack traces. Understanding exception chaining is also helpful. Sometimes one exception causes another. Python's exception chaining features show these links, giving you extra clues for debugging. In summary, tracing Python exceptions in complex call stacks is about capturing the full traceback using the Traceback module. Reading and analyzing this information helps you find the exact source of errors, understand how they happened, and fix bugs more efficiently.